Jai Hind everyone, myself Ankita, faculty of Department of IT, AKGEC. Today I am going to discuss topic neural network of Unit 4 for the course PCS 055. So the content I am going to cover is an introduction to artificial neural network, perceptron, multilayer perceptron, gradient descent and the delta rules and the multilayer networks. Now basically what is neural network? The neural network is nothing, it's a machine learning program which make decisions in a manner similar to human brain does. So as we as a human make decisions to a certain problem, in the same manner your neural network is also making a decision. So it is basically mimicking the biological neurons, how in our brain the different biological neurons work together to reach a decision. In the similar manner in neural network also we have artificial neurons that work together to reach to the decision. So artificial neural networks work collectively and concurrently imitating biological neural networks. So as we have a neural network running in a system to which we use to take any decision, in the same manner artificial neural network also have a network of neurons. So it is mainly it is used in various fields like regression problems, pattern recognition, recommendation and weather forecasting. So we have many applications of your neural network rather than what we are using right now is your LLM. All LLMs are inspired by your neural network. So these LLMs are basically transformer models which are inspired by a neural network. So it is the basis of all the current happening that we are seeing in your artificial intelligence. So the famous Google search algorithm is also based on your neural network. Now, as I have told you that the neural network is based on how our brain function, how we as a human biologically take decisions, in same manner the neural network also works. To understand that, we have to understand the structure of the biological neuron. As you can see here, this is the structure of a neuron. So our our body consists of millions of neurons that connect and work together to pass all the signals to the brain which take the decisions, right? So this is the structure of a neuron, a biological neuron, in which we have dendrites, then we have a cell body, we have an axon and we have the axon terminals. So the purpose of dendrites is to take inputs. So whatever input the neuron is taking, it is getting from the dendrites. Then cell body take all the decisions. So the main decision making process that happens in your cell body. Then we have an axon and we have axon terminals. Now these axon terminals transmit the output to the next neurons. So basically our body consists of a network of neurons in which each neuron is receiving input from other neurons from the dendrites and it is giving the output to the through axon terminals to other neurons or to your effectors. Now similar to human brain, that as in the human brain we have neurons, we have a artificial neuron. So as we have a nucleus or a cell body in which we take decisions, a neuron take decisions, we have a node. So we represent a cell nucleus as a node. Then we have dendrites which take the input. So in artificial neuron also we have input. Synapse is how the two neurons communicate with each other by the synapse of axon terminals of one neuron to the dendrites of the other neuron, right? So that is represented by weights or interconnections, and axon is your output. So by which axon is giving you the output, right? So whenever two neurons are connecting with each other, there is a transmit of signals which called as synapse. So we can say the two neurons can connect based on whatever signals I have, right? To corresponding to that, we have some weights. Now, when we talk about an artificial neuron, it is just similar to the structure of a natural neuron. So in which we have an input layer in which the input values are passed to the neuron using this layer. Okay? So similar to the dendrites of the biological neuron. Then I have synapses. Synapse means the one neuron is connecting to the other neuron. So whenever there is a need of one neuron to connect to other neuron, the axon of one neuron connects to dendrites of the other neuron, and this process of transferring of information from one neuron to the other neuron is known as synapse. Similarly, we have nodes in your artificial neural network, and these nodes communicate with each other through some signals. Now these signals are represented by the weight. Okay. Now whenever if there is a strong connection between the two neurons, there will be a weight associated with each neuron. So I suppose this is my one node and this is my another node, and these nodes are being connected with each other, and this connection is represented by a weight Wi. Now Wi will represent the strength of the connection between these two nodes. It depends upon the situation. Now we have a summing function. Summing function is basically how a neuron is taking care of the inputs it is getting. Now basically it does nothing but it forms the sum of all the weighted connections. So I have suppose multiple inputs, and with each input I am connecting to the other node and I have some weights associated with each. Now when I when I form the weighted sum of this W1 Xi, it forms the summing function, that it is present at every node. Then we have an activation function. So activation function decide whether or not the neuron is fired based on the output value. So basically it converts the output that we receive from an summing function to the actual output that we need. Then the output layer will give the final output to the neural network, from the neural network. Now, when we talk about the neural network, the first thing that we need to understand is your perceptron. Now, the perceptron is the simplest neural network that is possible. So, neural network, that is perceptron, was designed in 1958. So, it is so long. It's so old that the concept of perceptron has emerged. So, it was given by Frank Roosevelt. So, the perceptron is a type of neural network that performs binary classification. The purpose of perceptron was give you the output as a binary, the yes or no, 1 or 0. Okay. So perceptron consists of single layer of input and node. So in perceptron we have only two layers. First is your input layer, in which we have the input node, and then we have output layer, in which we have the output nodes. And also perceptron works only for the linearly separable pattern. So what is linear separable data? In which we can divide the data into two different categories without any issues. So when we talk about perceptron, there are two types of perceptron. First is your single layer perceptron and your multi-layer perceptron. Now single layer perceptron work well in case of your linearly separable patterns. Here we can divide the data into two distinct categories by a straight line. So suppose I have my data points like this, and this is characterized at one class, and this is characterized as one class, right? Other class. So when I am able to find a decision boundary, so we can say this is your linear separable data. Here I can distinct the categories by drawing a single line. Now suppose I have data like this. This belongs to one category and this belongs to other category. So in such cases, I am not able to divide the data into two different categories. So this is known as non-linearly separable patterns or data. So single layer perceptron work well in such cases where the data is linearly separable. In case of multi-layer perceptron, we have multiple layers. So in your single layer perceptron, we have only input layer and output layer, whereas in multiple layer perceptrons, we have more than two layers, we have hidden layers, right? So hidden in such cases, we is able to handle the complex patterns easily. Now, when we talk about single layer perceptron, as I have told you, it was introduced by Frank Roosevelt in 1958. It is a binary classifier. It will give you the output yes or no, or 1 or 0. So the perceptron algorithm is one of the first algorithm that has implemented a simple neural networks. So it is a supervised learning algorithm and is type of ANL. So what we mean by supervised learning algorithm? It means that whenever we are feeding the data to the neural network to get it trained, we give them input as well as output. So the data is labeled. So when the data is labeled, we call it as supervised learning algorithm. And single layer perceptron is also a supervised learning algorithm where while training the neural network, we provide them with the labeled data. Now, when we talk about the perceptron, the single layer perceptron, these are the four important concepts that we have. The first is your input. So a perceptron can take multiple inputs. So it can range from x1, x2 or xn, and each will represent a feature of the data. Now we have weights. Now each input is associated with a weight, or we can say each connection of the input node to the other node, right, will have some weight associated with that, right. Then we have a bias. Bias is added to shift the decision boundary. So it is just a default value that we add to our result to shift the decision boundary according to our requirement. Then we have an activation function. So activation function that processes the sum of weighted inputs and bias to produce an output. So remember, like SOMA, like each node will perform a weighted sum of whatever input it have with the weights, right. Now with that we have to translate that output to a classification, for example yes or no. For that we need to apply activation function. So in a simple single layer perceptron, the activation function that we apply is your step function. The step function is very simple activation function, which says that if my weighted sum is greater than 0, then I will give the output as 1. Otherwise, if my weighted sum is less than 0, my output will be 0. So weighted sum plus bias. Now this is the output that will be received by the weighting function, and then if that sum is greater than 1, greater than 0, I will give the output as true or 1. Otherwise, I will give the output as false. Now we can say understand the whole structure with the help of a diagram. So we have inputs x1, these x1, x2, x3, x4. These are my inputs. All right. Now what I will do, this is the connecting to, this is my input layer and this is my output layer. Okay. This is my one layer, input layer and output layer. And what happens in between, we have a summing function. What it does, it sums, it forms a weighted sums of the input. So we have W1 x1 plus W2 x2 plus W3 x3 plus W4 x4, right, plus bias. So this is called as weighted sum. All right. Now whatever answer we got out of this weighted sum, we will pass it through an activation function. Okay. Now in activation function, I have used a step function. So if this output is greater than 0, okay, I will give the output as 1. And if this weighted sum is less than 0, I will give my output as 0. So basically this is a simple structure of your single layer perceptron. Now when we talk about the training process, how my single layer perceptron get trained with the label data, this is the algorithm. Okay. Now we will first set the initial weight W1, W2 and Wn. So initially when we have started the training of your neural network, we don't know the weights. Okay, we know the input, but we don't know the weights. Basically when we are training our neural network, we know now we are training with the label data set. So we are training our neural network with labeled data set. Okay. So in labeled data set, I will be having the inputs. So let's suppose input is x1, x2, x3. This is given to us, and I will also have my output, suppose y. So in my data set, I will be provided with the input as well as the output, right? Now these weights W1, W2, W3, W, we don't know that. So after training, I will be able to understand these weights. What is the value of W1, W2, W3? So basically, while training neural network, our purpose is to learn the values of W1, W2, W3 and W4 plus learn the value of the bias. So once I learn the value of this weights and bias, I can apply the same formula and give out the results for new set of inputs. Okay. So that is how we work. So initially the W1, W2, Wn and the bias we will be setting to a random value which can be in the range of -0.5 to 0.5. So initially when we have just started the training, we will be giving the values of these weights as minus 0.5 to 0.5. Now for each epoch, what is epoch? Epoch is an iteration. So one iteration of your neural network training. I will be computing the weighted sum by multiplying the inputs with the weights and add the product. So what I will do, whatever input I have, I will be multiplying those output with the weights, and for example W1 X1, W2 X2, right? So I have guessed, or I have just set the initial values of the W1, W2, W3 to a random value, and now I will be multiplying the value of these weights with your X1, or you can say input. Okay. Now when I multiplied them, I will get some weighted sum plus bias also. Suppose Y dash. Okay. Now what happens? Now I have to apply the weighted sum on this Y dash, which will be a step function. So I will be applying a step function of the Y dash. Now I will receive an output like Y. Okay. Now I will be having this value Y desired, because I am using supervised learning. My algorithm will be using the trained data set. So I will be having this value as Y desired. Now this is the value that I got. Okay. Now there should be some difference between these two. Why? Because now my weights are not trained. Okay. So what I will do, I will try to find out the error. So this is my error. Whatever I wanted my answer to be, and what I got. So based on this difference, I will find out the error. And then I will update the weights. Now, since my weights are not correct, I have to update the weight. So I will be using the formula alpha multiplied by ET multiplied by XI. Alpha is the learning rate, at which rate I want my weight to increase or decrease. ET is the error, and XI is the input. So this is the formula of delta W. Then I will be updating the weight. For next epoch, now my weights are updated. For now, my next epoch, I will continue this process again till my error is minimized to 0. So we will take an example. So suppose this is my formula, okay, weighted sum plus B, okay. This is the value of my activation function, and this is the formula of my weight update rules. So initially, now this is the, I am training my network for the AND function. So when we talk about AND function, I have these my two inputs, 1, 1, target is 1. So when both are true, my target means what is my expected output. True, 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 false, 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 true, false, 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 false. This is my target. Now when I computed the Y in, so what is Y in? Y in the weighted sum. This is my weighted sum. So if I talk about this, let's compute this. Now my initial weight was W1, W2 is 0. So what I will do? 1 multiplied by 0 plus 1 multiplied by 0. My bias is also 0. Plus 0 will give me the answer 0. So my Y is 0. Now expected output was 0, and I also got 0. So the error is okay. So when I multiplied 1 multiplied by 0, this multiplied by 0, and my weighted sum is also 0, and my output get 0. Fine. So this is how I got 0. Now I applied the step function. My step function says if my Y in is equal to 0, the output will be 0. Okay, this condition will happen. Now output is 0 by applying the step function. This is weighted function. This is after applying the step. This is actual output. Now I should get 1, but I got 0. So error is of t minus y is 1. Okay. Now I have to update my weights. Now the formula of weights is W1 is equal to W. W initial was 0. Alpha is 1. t minus y is 1 and xi is 1. So my output, now my weight will be 1. Okay. Similarly, for W2, my weight will be 1 and my bias also will be 1. So I have applied the same formula on these values. So after the end of epoch 1, I will be getting the values as W1 is equal to 1, W2 is equal to 1 and B is equal to minus 3. For next epoch, I reach to the error rate as 0. This is when I have to stop. So that was my AND function using perceptron rule. I was able to train my neural network for learning the logic of your AND function. Okay, and the whatever weight I got was W1 is equal to 3, W2 is equal to 3, B is equal to 1, minus 1. So now whenever I will get my any output or any input of x1 and x2, I can apply the same set of formulas. Because now my model is trained, these values are fixed, it will give me the correct output. So I will get the correct output in case of my AND function, right? So next topic is your gradient descent and delta rule. So as I have told you, the single layer perceptron works well in the case of your linearly separable data. So when we're talking about AND gate, OR gate or NAND gate, when the data was linearly separable, I was able to use the single layer perceptron and I was able to reduce my error to 0. But in case when the data is not linearly separable, for example in XOR. So what is the truth table of XOR? If it's true, true, it will give you the answer false. If it is false, true, it will give the answer true. True, false will give you true and false, false will give you false. So when I try to plot it, you can say this at 1 and this. So I am not able to distinguish these 2 points. How the data here is non-linearly separable. So in case of XOR gate, my linear perceptron fails. So in such cases, we use second training rule called as delta rule, where I use gradient descent to search the hypothesis space for possible weight vectors to find a weight that best fits the training sample. So simple is that now when we try to plot the error with the weight, now I know that error cannot be reduced to 0, but I have to reach to the area of minimum error. For that, I will be using the gradient descent. For example, if I plotted this 3D model to a 2D, I can say this is the winner. Okay. Now, when we talk about delta rule, it says this is my weighted sum. All right. Now, for this weighted sum, I have to find out the error. Now, error is defined as this: half minus TD minus OD ka whole square. TD is your target output and OD is actual output that I received. So I have to, when I talked about steepest descent, what I have to do? I have to find out this slope. Okay. So I have to find the error, the gradient of the error. For that, I have to use partial derivatives of error with respect all the weight values. For that, I have the formula as W is equal to W plus delta W, and delta W is this formula that we have learned for your single layer perceptron. Same minus neta, that is learning rate, and delta is I have to reduce this error. Okay. Now, delta W is equal to minus neta gradient of minus EW. So, when I talk about del E upon del W is equal to half of, this is what my error is, delta E. This, I have to find out the gradient of error with my weights. Okay. So, now when I try to differentiate it, I will get the values as half to simple rule of differentiation and del of this. Now, this is constant. As we know, this is constant. This will cancel out and this is constant. So, I will reduce then and what I will get? OD. Now, for OD is equal to WX. Okay. From this. So, this is ultimately I get delta E upon delta W is equal to this. Now, when I apply on my delta W, my output will become this. So, this is my delta rule of back propagation. So, when we call of multi-layer perceptron, in multi-layer perceptron, we have input layer, hidden layers and the output layer. So, whenever we have non-linearly separable data, we use multi-layer perceptron in which we have additional hidden layers. Okay, now when you talk about multi-layer perceptron, the function is as same as that of your single layer perceptron. Here we have forward propagation where we form the weighted sum and then we apply the activation function. Now here in multi-layer perceptron, the activation function that we apply is sigmoid, ReLU or 10H. Then we have a loss function depending upon the problem. If it's a regression problem, we use MSE, mean square error, that is half TD minus OD ka whole square, and for classification we use cross entropy. And after finding out the errors, I have to back propagate this error to the neural network, to the hidden layers. Now earlier we don't have the hidden layers. Now here now we have hidden layers. I have to back propagate this error through the hidden layers. Okay, so that is how we are using back propagation. This is another topic to discuss. We will discuss that in the next video lecture. So we will be using chain rule and gradient descent for that. Okay, so in this video lecture we have discussed about the basic of neural network, single layer perceptron with an example, and introduction to multi-layer perceptron. Thank you.